So we are now on to 2.2, and this is all about trig ratios of any angle. So I would say this is probably one of the more difficult sections of our trig adventure in Math 20-1. So we're going to do a lot of examples here, and we're going to go through, so make sure we're paying attention, and we're learning lots here. So I'm going to be doing and introducing you to what we do in terms of when we're given a coordinate point. So anytime you're given a coordinate point in trigonometry, you can essentially create a terminal arm, okay? And that terminal arm, we can create an angle. So when you're given a point, plot the point on your Cartesian plane, and then we can start talking about the angle that that arm creates with the x-axis, right? So at this point, we can develop ratios, finding trig ratios for any angle, as long as we use certain conventions. So a few things to note. When you're given that point on your Cartesian plane, and then you decide to create your terminal arm, that thing has become what we call r. So r, some things to note, is always positive. Okay, no matter where it's found in the Cartesian plane. Now, as soon as you draw r, there's a few things that happen. You can then drop down your leg here, and then you can see now we have a right triangle. So now we're dealing with a right triangle, so there's a few things that we can do in terms of when we're dealing with a right triangle. Now ask yourself, how high, what would be the measurement of this length? Well, it would be y high, because remember, this would be y here, so this is going to be y length. And then this length here, what would that be? Well, that would be x. So this would be x length. And now you can see we have a right triangle. We have a right triangle that we can talk about in terms of y, x, and r. So we're going to talk about the trig ratios in terms of y, x, and r. So first we're going to talk about sine. Then we'll talk about cos, so ca. And then we're going to talk about tan, so to. So first off, we're going to be talking about this angle, okay? And sine angle is always opposite over hypotenuse. Now, as we move forward in our trig adventure, and as we get into higher mathematics, we're talking a lot about Cartesian planes. We're always talking about coordinate points and vectors, or the terminal arms that those points make. So we don't really usually talk about it in terms of opposite and hypotenuse. You still can, and it will help you learn. But now you can start thinking about it in terms of what is my angle and what's the opposite to that angle. So here, there's a few things to note. This is the opposite leg. This is the adjacent leg. And here's our hypotenuse when we're talking about this angle. So now we can put in terms of sine angle here. Well, opposite we just said is y, so this would be y over our hypotenuse, which is r. So there is your trig ratio in respect to a point on a Cartesian plane. Then we have cosangle. Cosangle is adjacent over hypotenuse. Now what's your adjacent leg here for this angle? Well, it's x. So we can represent cosangle in terms of x over r. And now finally, tan is opposite over adjacent. And the question is, well, I know my opposite side length of my angle is y, and my adjacent side length is x. So this will become tan angle equals y over x. And now this is the way you want to think about and interact with your trig ratios when you're given a coordinate point you draw the terminal arm, and now you're talking about your trig ratios. Okay? So kind of get used to this. We're going to explore this idea a little bit more moving forward. Now, let's think about the different quadrants here. So I'm going to just draw a little section here. And we're going to talk about the trig ratios in terms of each quadrant. So this will be in quadrant 1. This will be in quadrant 2. This will be in quadrant 3. And this will be in quadrant 4. And in each little quadrant, I didn't use Roman numerals in the rest of them, so I may as well use regular numbers there. So recognize I'm going to draw a little Cartesian plane in each thing. So let's focus when we're in quadrant 1, and I'll draw a little focus quadrant here. So let's say we're given a point that exists here. So this is x and y. And then again, what you're going to do every time you're given a point is you're going to draw a line leading up to there. And now you have a right triangle being formed. And then you're given an angle. We already went over this one a few seconds ago. This is length y, this is length x, and this is length r. Again, we have our sine angle being the opposite, so y, over hypotenuse, which is r. And then what is cos here? Cos angle is adjacent, so x over r. And tan angle would be opposite, so y over adjacent, which is x. Some things to note here is all of these values are positive. All ratios are positive. And why is that? Because y is positive, x is positive, and r is always positive. Now, hopefully you can think about what happens if we have a coordinate point living in quadrant 2. Then my y value is still positive, but my x becomes negative. So your trig ratios are going to change in terms of their signs. So I'm going to generalize this. So this is when an angle is greater than 0 and less than 90 degrees. Okay. Let's move over to quadrant 2. So this is when your angle is greater than 90 degrees, but less than 180 degrees. So again, let's draw a Cartesian plane. And let's say we're given a point, some point, where we have a negative x value and a positive y value. So if I plot that point, it's going to live somewhere in here. And then again, anytime you're given a point, draw a line connecting it, a terminal arm, where the vector or the point is now here. And now we're going to focus on our reference angle. So you're going to use reference angles here to determine the standard angle ratios. So we will use reference angles to determine standard angle ratios. And because remember what reference means. Reference means we're just going to use it to understand something else. So we're going to reference this angle to create the trig ratios, but it's actually finding the standard angle ratios. So yet again, what can we do here? Well, we can drop down our point and form a right triangle. And then as soon as you have a right angle triangle, then we're dealing with SOHCAHTOA. So again, this length here is negative x. Okay, we're dealing with a negative x value now. This length here is positive y. And then remember, our terminal arm is always mentioned as r. So now if we start talking about our sine angle, so remember sine angle is opposite over hypotenuse, cos angle is adjacent over hypotenuse, and tan angle is opposite over adjacent, we can now put it in terms of our new sign conventions on a Cartesian plane. So in this case, what does sine angle equal? Well, sine angle, we're going to talk about the reference angle. If we reference this angle, the opposite to the reference angle is y over the hypotenuse, which is r. So that's still positive. So understand again, we're using our reference angle to understand the trig ratio for the standard angle. So this also means that our standard angle ratio of sine is y over r as well. So there's our first trig ratio. Now let's focus on our next one, cos. So our cos angle, and we're going to use the reference angle first, and then that will help us understand the standard angle. At this point, we will do adjacent over hypotenuse. So now notice this is a negative x. The adjacent side length to the reference angle is negative over r. And that means we have actually found the standard angle ratio, which would be negative x over r. Now recognize sine, or cos, is now negative. And then now what would tan be? Tan angle for our reference is opposite over adjacent. The opposite side length is y, adjacent side length is negative x. So we get y over negative x. And again, we're using our reference angle to actually find the standard angle ratio, which would be y over negative x. So what do we notice here? We're noticing that sine is the only one positive here. Our ratios, so at this point, sine angle in quadrant 2 is positive. We also notice cos angle and tan angle in quadrant 2 is negative. So I guess that shouldn't be an S, this should be an N. Okay, so hopefully you see what we're doing here. We're analyzing the standard angles by using the reference angles. Okay, so let's go to quadrant 3 here. And let's check out this one. So again, quickly draw out a Cartesian plane. And let's say we're given a point, negative x, negative y. So if we're given a point negative x, negative y, we're going to be found somewhere down here. And again, what you're going to want to get used to, as soon as you're given a coordinate point, draw a terminal arm. And now at this point, you are dealing with another right triangle. So we drop down our point here. We have a right triangle. And remember, we're talking about our standard angle. But in order to understand the standard angle, we're going to analyze it through the reference angle. Okay. Now, recall, a terminal arm is always represented as r. And r is always positive. You kind of want to tattoo that on your forehead. R is always positive. So always remind yourself about that. And now at this point, we can kind of analyze SOHCAHTOA here. We can analyze the sine ratio, the cos ratio, and the tan ratio. So here, if we want to know the sine ratio for the standard angle, we are going to use the reference angle. So that equals the reference angle sine ratio. And what does sine equal again? We'll recall sine is opposite over hypotenuse. So what is the opposite leg of angle R? Well, that would be our negative y value. And then our hypotenuse is R, so we can maybe plot this down. This is our opposite side. This is our hypotenuse. This would be the adjacent. And at this point, hopefully you can see that this is also a negative x. So we can start noting this down. Again, sine is opposite, so negative y over hypotenuse, r. So hopefully you can see sine is a negative value. Then let's look at the cos ratio for the standard angle. And we're going to use the reference angle to understand it. And remember, cos is adjacent over hypotenuse. Okay, so you always got to remember, SOHCA TOA. So what is the adjacent side of cos? Or sorry, the reference angle? Well, that's negative x. So this would be negative x over the hypotenuse, which is r. And there is our other trig ratio. And then we're going to look at tan, finally here. So again, to understand the standard angle tan ratio, we are going to analyze it using the reference angle for tan. Now at this point, tan is opposite over hypotenuse. Opposite is negative y, hypotenuse, or sorry, opposite over adjacent. Opposite is negative y, adjacent is negative x. So this will be negative y over negative x. Now here's something important to note. A negative and a negative dividing each other give us a positive. So tan is actually a positive value here. Okay, so let's recognize some stuff. This is a negative ratio here. This is a negative ratio here. And then this is a positive ratio here. So when you have an angle that lives in quadrant 3, and if an angle lives in quadrant 3, that means this angle is greater than 180 and smaller than 270. Okay, so remember this is 180 here, this is 270 here. When you have something that exists in this quadrant, the only ratio that is positive is the tan ratio. So tan ratio is positive. Whereas cos and sine are negative. Okay. And then hopefully by this point, you might be able to actually understand what quadrant 4 is based on what we've done here. So if we fill out quadrant 4, let's plot a point P where if we live in quadrant 4, your x is positive and your y is negative. So we would have a positive x and a negative y value. Okay. And again, as soon as you get a point, plot it on your Cartesian plane and draw a terminal arm. Recall what the terminal arm is. It is length r. R is always positive. And then at this point, you can drop down a value. That was a little off. Let's do this. You can drop down your value. I guess it wants to go there. Just move it over a little bit. There we go. Whatever, that'll work. And now at this point, again, you have a 90 degree. Realistically, we are talking about the standard angle, but to understand the ratios of that standard angle, we are going to reference the reference angle. The reference angles always help us understand standard angles. And now we can fill out the fact that we know this is distance positive x, and this is distance negative y. And now we can start talking about our ratios. So if I wanted to know the sine ratio for the standard angle, I'm going to reference the reference angle. Remember, sine is opposite over hypotenuse. So what's the opposite leg to our reference angle? It's negative y. And then my hypotenuse is r. Let's talk about the cos angle for the standard angle. Again, I will use the reference angle to understand this. Cos is adjacent, cos is adjacent over hypotenuse. What is the adjacent side length? The adjacent side length would be positive x over r. And lastly, we're going to deal with tan. So we're going to find the standard angle tan ratio. And in order to understand it, we are going to use the reference angle. And at this point, my tan ratio here is opposite over adjacent, so negative y over x. Now what do we see here? We see a few things. That sine is negative, tan is negative, and cos is positive. Okay, so what does this mean? This means that we have a generalization here. And in order to understand these, we are going to use what's known as the cast rule. Okay, so down below, we're going to use the cast rule to understand this. This essentially tells us which ratios are positive in which terminals. Which ratios are positive in which terminals. Okay, so if we look here, cos, your cast starts in quadrant 4. So C-A-S-T. Our cosine is positive in quadrant 4. All of them are positive in quadrant 1. Sine is positive in quadrant 3. Tan is positive in quadrant, this is quadrant 4, quadrant 1, quadrant 2, quadrant 3. And we can see this is true. If I write out my cast rule here, maybe we'll do it very small. Cast. What was positive in quadrant 4? Well, we found that cos was the only positive ratio. In quadrant 1, we found that all of them are positive. In quadrant 2, what did we find? We found sine was the only positive one. And then tan was the only positive one in quadrant 3, as we can see here. So it's just a way to remember what all that means. So I'm going to show a really quick example of what I mean by using the reference angles to find these standard angles before I move forward. So I'm just going to make a quick example on my own here, just to kind of understand what the heck we're talking about. So at this point, if we have a point, let's say found right here, and let's say this point is -3 and 4. Okay, so again, we would have 4 here and -3 here. Let's say we want to determine all 3 trig ratios for point -3 and 4. So this is going to be a type of new question to you. You've never seen a question laid out in such a manner. So we're trying to determine all 3 trig ratios for point -3 and 4. So what are we talking about there, and what do we mean? We're actually talking about this standard angle here. We're talking about the angle at which creates this terminal arm that forms between -3 and 4. But to understand that and to be able to use our trig ratios, we're going to reference our reference angle here. Okay, so in order to start this up, I'm going to drop down my point, and again, that creates a 90-degree angle. And I know the side lengths of all these things. This is +4, this is -3, and this is r here. So in order to figure out all three trig ratios, let's understand that we're going to figure out the sine ratio for the standard angle, but I'm going to use my reference angle in order to understand this. Recall all about your SOHCAHTOA. Okay, so we have SOHCAHTOA at this point. And in order to understand SOHCAHTOA, we are going to use opposite over hypotenuse to find sine. So this is opposite over hypotenuse. And what is opposite over hypotenuse? Opposite over hypotenuse, in this case, is for our reference angle 4 and r. So here we know that sine angle in terms of x, y, and r will be y over r. We know what y is. Y equals 4, x equals -3, but we don't know what r is. So how the heck are we going to find r? Well, you can use Pythagoras Theorem. We know that this is a right triangle, so we can do a squared plus b squared equals c squared. And in Math 20-1, you want to get used to saying this: x squared plus y squared equals r squared. That was weird. That should have been a square there, not r. So now at this point, we can start finding r. We can start finding r by plugging in the values we know. Here, x is -3 squared plus 4 squared equals r squared. -3 squared is 9 plus 16 equals r squared. 9 plus 16, of course, is 25, equaling r squared. And then I'm going to square root both sides. So 5 equals r. And remember, r is always positive. Okay, so this equals 5. So now finding our trig ratios is going to be pretty quick and easy, because it's a matter of just plugging in the values we know. So since sine angle is y over r, we can quickly say that the reference angle here for y over r, y we said is 4, r is 5. So my standard angle, reference angle, is 4 over 5. Done. Now let's do cos. So the standard angle cos ratio would be equal to my reference angle cos ratio. And remember, cos angle is equal to x over r. So my x value is -3, and my r value is 5. So here we know that the standard angle of cos is -3 over 5. And then we can finish this off with our tan angle. So recall that tan angle equals, again, it's opposite over adjacent, but in this case it's y over x. So my tan standard angle is equal to my tan of my reference angle, and the y value here is 4, and the x value here is -3. So the standard angle ratio for tan is 4 over -3. And we can see here, remember, for our cast rule, what should be the only ratio that's positive? Sine. And is that true here? Yes, sine becomes the only positive ratio that we see. So I'm going to stop the video there just because that was a lot to kind of soak into your brains. So make sure you go practice this. Understanding the generalization is really important. That was a really quick example. So if you're feeling confused, please come and ask some questions. Okay. But something, I'll be doing another video where we go through quite a few examples. Okay. So go practice some problems, maybe watch another video if you need to solidify some understanding. And if you're very confused, please just send an email. Other than that, have a good day.